So here we've got a question about echo sounding. So there's a few things we need to think about when we start reading this question. And I think the first thing that comes into mind is that what is an echo? So an echo is just a reflection of a sound wave. So if you have a surface, then an incoming sound wave would reflect off that surface, obeying the law of reflection, which states that the angle of incidence, this angle here, is equal to the angle of reflection. An echo sounding is a way that fishermen use to work out how far away fish are or how far away their boat is from the bottom of the ocean. So let's have a go at answering this question. It says sound waves are being emitted from a fishing boat. And I think with a question like this, it's so important that we imagine what's going on here. So if I draw a little thought bubble down here, and then we can imagine what's going on in this question. So let's say we've got our ocean waves like this, and we've got our boats sat on top of the ocean like this. Now, of course, we need to have some fish in the sea, and then we need to have the ocean floor at the bottom. And so as the boats move along, they emit these short pulses of sound waves, and the pulses travel down through the sea until they hit a fish. And then when they hit the fish, that pulse will reflect back. And then the pulses continue travelling down, but a bit of the pulse has been reflected. And then it might hit another fish. And so that bit of the pulse starts being reflected back towards the ship. And so the rest of the pulse carries on travelling down until it hits the sea floor, and then it gets reflected back to the ship. And so it comes out as a really tight, packed together, short pulse. But because it gets reflected at different points, it gets stretched out, because this first pulse is going to get back to the ship a lot quicker than this pulse that went all the way down to the bottom before being reflected by the sea floor. So now we've pictured what the problems might be. Now it's time for us to think about what the rest of the question is really going to ask us about all of these ideas. So it says, the shortest time between sound waves being emitted and detected is 0.26 seconds. And then it says the speed of sound in water is 1.5 kilometers per second. Already, I'm thinking, here's a problem. I never use kilometers a second, so I've got to convert this into meters per second. So if we've got 1.5 kilometers, there are 1,000 meters in a kilometer, so we've got to multiply 1.5 by 1,000, and we get 1,500 meters per second as the speed of sound in water. Now it's asking us to calculate the distance between the boat and the nearest fish. So imagining again this situation that we've got here. So we've got speed, we've got time, and we've got distance. So it springs to mind one of the most popular equations in physics, speed equals distance divided by time, but we're being asked for distance, so we've got to rearrange it, and if we've got distance over time here, we want distance on its own, it's divided by time, so we do the opposite, we multiply both sides by time, so we get distance equals speed times time. So now let's substitute in the numbers. We've got 1,500, we're going to multiply that by 0.26, and that gives us 390 meters. Now, alarm bells are ringing because it says 4 marks. Now, I don't think I've done 4 marks worth of work yet. I've probably only done about 3 marks worth of work. I've rearranged the equation. I've converted the kilometers per second into meters per second. I've substituted in the numbers. But let's just think about what we've got here. We've worked out the distance that the sound has travelled in 0.26 seconds. But the sound has gone down to the fish, been reflected back up. So the sound has travelled twice the distance between the boat and the fish. So this is the distance that the sound has travelled. So the fish must be half of that distance. So that's going to give us our final answer of 195 metres. So, part B. Each sound wave is emitted for a very short time. The reflected sound wave received by the boat lasts a longer time. Suggest a reason for this difference in time. Now, this is why it's so important with a question like this. We think about the situation before we start reading the question. That's going to help us answer any question that the examiner might throw at us. So it's saying that the pulses or the sound waves are emitted in a short amount of time, and then the reflected sound wave is much longer. And we're going to remember that this sound wave gets emitted bunched up like this, but bits of the sound wave get reflected at different parts, whether it's a fish here, another fish, or the ocean floor. And so some of the sound wave gets back to the boat very quickly, but the rest of the sound wave has to go all the way down to the bottom before being reflected back up to the top. And that's how we're going to answer this question. So, some of the sound wave is reflected by fish. Some is reflected by the ocean floor. So, different parts of the wave travel further. Therefore, the pulse or sound wave is stretched.